In this video, I'm going to discuss addition with natural numbers. Natural numbers, you'll remember, are numbers like 0, 1, 2, 3, 4, etc., etc. Those represent quantities, for example, numbers of cell phones, sheep, erasers. All right. So what does it mean when we take two numbers, two quantities, and put a plus symbol in the middle? Well, you had two quantities previously, 2 and 3, and now combining them, how much would you have altogether? So in this case, 2 pencils and 3 pencils, you'd end up with 5 total. Excuse me. So we write that with an equal sign, and then we put the new single number on the right side. That's one way to do it. All right, and then you can do other examples all day long. All right, so let me now show you how to think of addition on the number line. Let me show you some properties of addition that may or may not have occurred to you unless you stared at it and thought about it for a while. And then I also want to talk about a trick to add many large natural numbers. Okay? So you need to know positional notation for my trick, which I covered in a previous video. So here we go. Alright, so you can think of 2 plus 3 equals 5. You can think of the fact that you are standing on the number 2, and what happens is when you have a quantity 2, and when you increase the quantity by 3, you combine it with a pot of 3 goldfish or whatever, an aquarium of 3 goldfish, whatever. 1, 2, 3, so you end up right here. All right. So addition is moving to the right. All right. Now, this might not be obvious. So 2 plus 3 equals 5. Now, it just so happens that if I was standing on the 3, and instead of hopping, like when I started on the 2, I hopped 3. But what about if I started on the 3 and hopped 2? I would end up at the exact same place, wouldn't I? So what that means is that 3 plus 2 is also equal to 5. So all that is to say that the order does not matter. Whenever you add things, 2 plus 3, 3 plus 2, 100 plus 17, or 17 plus 100, you can do it in whatever order you want. All right, go to town. It doesn't matter. This is called, if you want to know the fancy name, this property is called the commutativity property. We say that addition commutes. All right. Now, there's another property that I want to talk about. Let's now focus on adding 3 quantities together. All right. So suppose I did 1 plus 2 plus 3. Okay. That's certainly, well, first we have to ask ourselves, how do we add 3 things together? Okay. You've got, what if we first mix the first 2 numbers in a pot? So that 1 plus 2 will give, these will combine to give 3. All right, so let's replace it with 3 plus 3, and that would give 6. Okay. Now, instead, what would happen if we first combined the second and third numbers in a pot? So what I'm talking about there is, let's say, let me rewrite the original problem. And let's combine the 2 and the 3 in a pot, so that gives 5. So we would do 1 plus 5 as the next step. And look, we still get 6. All right. Now, to be clear, if you want to specify the order that you add things, you have to put parentheses. So in the purple example, I would, if I wanted the first 2 numbers to be added first, I would do that. Okay. In the second, the blue example downstairs, I would put parentheses around the second example, the second pair of numbers. All right. So, and it doesn't matter really, does it, which ones you add first. So all of that is to say the following pattern. So if you add the first pair, or if you add the last pair, it doesn't matter. Okay, and this pattern is true for any numbers. So if I had 5,147 plus 3 plus 99, that doesn't matter if I can do that. That's equal to 5147 plus 3 plus 99. See that? Okay, if you want to know, this is called the associativity property. We say that addition is associative. All right? And so in closing, let me show you the way to add lots of big natural numbers. All right? So 343 plus 205. Okay? So what I would suggest is that you make a vertical column. Okay? And remember, from positional notation, we said that the first the rightmost number represents a specific quantity. Like in 205, the 5 represents like 5 iPhones. All right. The next number represents packets of 10. So in this case, the 0 means I have no packets of 10 iPhones. The 2 represents packets of 100. So I have 2 packets of 100 iPhones. Okay. By by lining them up like this, each position of each number, the corresponding positions are lined up vertically. All right. So now you can add the 3 and the 5 and get an 8. The 4 and the 0, that's the packets of 10. So you have a total of 4 packets of 10. The 3 and the 2, you have packets of 100. That gives that. Okay. Now the only confusion might be if you have big numbers. Let me show you what I mean by that. 876 plus 945. Okay, so we lined them up. Okay, and let's figure out what happens now when we add the corresponding quantities. So 6 plus 5 gives a quantity of 11. All right, now an 11, we don't want to write a number bigger than 9. So what we're going to do is we're going to write the 1, and think of 11 as 1 and then the other digit as showing that you have 1 packet of 10. All right. Well, 1 packets of 10, that's the middle column, right? So I'm going to add another 1 to the packet of 10 column. Okay, so now let's add the middle column. 1 plus 7 plus 4 gives 12. So now I have the same problem. I've got 12 packets of 10. Okay, so I'm going to put a 2 here, and 10 of those packets of 10, well, that's equal to a single packet of 100. So I'm going to now add 1 to the leftmost column. All right, and so I add those, and then now I'm allowed to write something bigger than 9, and I get 1821. All right, and that's all I want to say about addition.